So today we've been asked to solve some inequalities, and specifically some absolute value inequalities. And before we get started, I want to remind everyone that when we talk about absolute values, what we're really talking about is if you look at a number line, okay, if you can picture a number line. Take this particular inequality here. We're saying that this quantity must be less than 9 steps from 0. So what that means, if you go 9 steps to the left of 0 and you go 9 steps to the right of 0, what this inequality is really saying is this quantity must be less than 9 steps from 0. So it must be in this range, okay? And typically, if you look at a college algebra book or you look at a pre-calculus book, they'll have a rule. And that rule says that all less than inequalities become and statements. And what that means is that your solution is between two specific numbers. Well, in this case, we're going to rewrite this as two equations, and we have to find those specific numbers. Okay? But basically what we're saying is, that this quantity must be less than 9, or it must be greater than -9, because we're saying this is less than 9 steps from 0. So this is exactly 9 steps from 0. Less than 9 steps from 0 would be greater than -9. If you understand that concept, then absolute value inequalities are very, very simple, because this is going to become two equations, two inequalities. 2x plus 3 is less than or equal to 9, and 2x plus 3 is greater than or equal to -9. It's what we're going to end up with, okay? And again, the reason for that is because we're saying this quantity is less than 9 steps from 0. Well, in the positive direction, less than 9 steps would be a less than inequality. On this side, to be less than 9 steps from 0 has to be a greater than inequality. Okay? So you solve these two inequalities, and you're going to get 2x less than or equal to 6, x less than or equal to 3. Okay? Over here, you're going to get 2x greater than or equal to -12. And then divide by 2, and you're going to get x greater than or equal to -6. Now, what does this mean? Well, it means that your solution, going back to the original premise of the problem, is going to be between 3 and -6. 3 and -6, okay? And so how do we write that as an inequality? Well, that's an and statement, and it's going to look like this. Right? X is between -6 and 3. Okay? And I don't need to memorize a rule for that. There is a rule in your pre-calculus book or college algebra book that will tell you that, but I don't really need to memorize a rule if I understand absolute values. So, moving on to the next one. I've got this equation here. 2x, absolute value of 2x minus 5 is greater than 25. Now, again, let's look at this on a number line. What does this mean to me? Well, it says that this quantity here is going to be more than 25 steps from 0. So here's 25 steps from 0. Here's 25 steps from 0. More than 25 steps from 0 would be shaded this way, or would be shaded this way. And that is an or inequality. Okay, that's an or inequality. And again, what we're looking at is greater than 25 or less than 25. Okay, so we're going to have less than -25. That's what we're saying. Okay, so this is going to break into two equations based on that premise. 2x minus 5 is either going to be less than -25 or greater than 25. So less than -25, and 2x minus 5 is greater than 25. Okay? Now, solve this. You're going to add 5 to both sides. You get 2x is less than negative 20. Divide by 2, you get x is less than negative 10. Over here, you get 2x is greater than 30, and x is greater than 15. And so you get these two solutions here, and you have to write them correctly. And think you're going to shade to the left, you're going to shade to the right. What does that mean? That means that x is less than negative 10 or x is greater than 15. Okay? Because again, you're going to shade larger than, okay, a larger distance than 25 from either side. So the third equation here, we've got the absolute value of 5x minus 10 is less than negative 15. Now, I want you to think about this for a second. Absolute values have to be positive because we're talking about distance. Absolute values can never be less than 0. They cannot be negative. So what I'm saying here is this quantity must be less than negative 15. It must be smaller than 0. Okay? That is not possible. And so the answer here would be no solution. Well, what if you were a poor, unwitting soul and you said, well, I didn't know any better, and you draw your little number line here and you say, okay, what does this say? This says that this quantity is less than, for all intensive purposes, 15 steps from 0. Okay? So we take negative 15 and we say positive 15. And less than 15 steps from 0 will be shading this way. Less than 15 steps from 0 will be shading this way. So this is an and inequality. Should be. So we work the problem. Let's just say we disagree with our teacher here and we work the problem. Okay? You get 5x minus 10, and if you look here, look at negative 15. It has to be greater than. And if you look at positive 15, it has to be less than. So greater than negative 15, and 5x minus 10 is less than 15. Okay? And we solve these. So we get here, we get 5x, and we add 10 to both sides. So we get 5x is greater than 5. X is greater than 1. And here we get 5x is less than 25. X is less than 5. And we said this should be an and inequality. So we write this as an and inequality, which is, wait a minute, here's the problem. X has to be greater than 1, but less than 5. Okay, so let's write that out as an and inequality, right? X is greater than 1, X is less than 5. Okay, so we got an answer. There's our answer, isn't it? But Mr. Murphy, you said there was no solution. Well, here's our problem. Try a number between 1 and 5. I'll pick a simple number, 3. Well, what do you get? I'm going to just come over to the side here. We get 5 times 3 minus 10 less than negative 15. All right, well, 5 times 3 is 15, so we get 15 minus 10. It's less than negative 15. Well, 15 minus 10 is 5. The absolute value of 5 is 5. 5 is less than negative 15. Is 5 less than negative 15? No. This is an untrue statement. This is a false statement. When you get a false statement, what does that mean about your solution? It means your solution is inaccurate. So, why is my solution inaccurate? Because absolute values must always be positive because they are talking about a distance. So, it's kind of a fun way to remind you to check your work, because let's say you didn't think of this and you went ahead and you worked this problem and you got this solution. Well, then when you check your answer, you get a false. What do you know? Either A, you worked it wrong, or B, you worked it correctly, but there is no solution. And that's the situation here. So let's look at problem number 4. x plus 3 absolute value is greater than negative 10. Now, similar situation to problem number 3. What we're saying is that this is going to be greater than a negative number. Well, since all absolute values are positive, all absolute values are greater than negative 10. All absolute values are greater than negative 10. So, since all of them are greater than negative 10, what do we say? We have infinitely many solutions. Okay, we have infinitely many solutions. Well, what if we don't see that? What if we just jump in and try to work this? Okay, again, I draw my little number line and I think about this problem for just a second. And this says to me that this quantity is more than 10 steps from 0. So there's 10, and there's negative 10. Okay, and more than 10 steps would be that way. More than 10 steps would be that way. So this has to be an OR inequality. And it has to be less than negative 10, or it has to be greater than 10. So I set it up just like that over here. So I write x plus 3 less than negative 10 and x plus 3 greater than 10. Okay, solve this. Well, it's really simple. We subtract 3, we get x less than negative 13, and we get x greater than 7. Okay, we have an OR inequality here. Okay, so we try a number less than negative 13. Okay, how about we say negative 15? Well, what's negative 15 plus 3? It's negative 12. What's the absolute value of negative 12? 12. Is 12 greater than 10? Sure. 12 is greater than negative 10. So we know that works. We try this interval. Number bigger than 7. Let's try 10. 10 plus 3 is 13. Absolute value of 13 is 13. Is 13 greater than negative 10? Sure it is. But let's go backwards for a second. I said there were infinitely many solutions. So let's try something in this interval in the middle. Let's try something in this interval in the middle. We'll pick a number between negative 13 and 7. Okay? Because our answer says it has to be less than 13, negative 13, or it has to be greater than 7. What if I pick a number in between? How about positive 1? Well, what's 1 plus 3? It's 4. Absolute value of 4 is 4. Is 4 greater than negative 10? Yes, it is. And so by finding something between these two that is also correct, that makes this solution incorrect, and it makes this solution here correct. And I have a real simple way of remembering this. An absolute value will always be greater than a negative number. You get infinite solutions. An absolute value will never be less than a negative number, so you get no solutions. So anyway, that's solving absolute value inequalities and kind of the way that I look at them. If you have any questions about this or any other problem, please let me know.